This is the second video on grounding and bonding in ham equipment and why we don't ground ham equipment. Article 250 is grounding and bonding. The express purpose for grounding and bonding is to create an effective ground fault current path. Not just anything we feel like installing, it is required to be effective. An effective current path is an intentionally constructed low impedance, that's critical, low impedance electrically conductive path designed and intended. Notice all these extra words: to carry current under ground fault conditions from the point of a ground fault on a wiring system to the electrical supply source. That facilitates the operation of overcurrent protected devices, ground fault detectors, etc. Realize years ago we didn't have ground fault detectors. That's very important. History is absolutely critical here, and that history comes from the 1920s, and we cannot thoroughly understand this question without going back to the 20s and starting over. Notice this is talking about electrical supply. Next page, general requirements. Ground fault current path. You can pause the frame and read these. Grounded systems. Notice it's important here to notice that this is on the supply side. Grounded systems does not say supply. Later on, a couple pages over, it starts talking about the load side. This is on the supply. The load side's mentioned in 250.24a5. Notice the repetition of the phrase normally non-current carrying conductive materials. That is critical. It does not say normally non-conducting current carrying wires. It means anything that conducts electricity, enclosing electrical conductors or equipment, armored cable, transformer frames, equipment housings or whatnot on the supply side must be grounded. Why? Shall be connected to earth so as to limit the voltage to ground on these materials. That way a potential cannot be developed between the equipment and the ground. Remember that. That's critical later. And I'll pause on each of these. You can pause the frame by putting the mouse, the cursor on the image and left clicking will freeze the video. Here's a critical point. Effective ground fault current path. Not anything we feel like putting in, not a minimum, not just what someone told us is good enough, but it has to work. Electrical equipment and wiring and other conductive material likely to be energized, low impedance circuit facilitating the operation of overcurrent devices, capable of safely carrying the maximum ground fault current, and circled and a big red star, the earth shall not be considered as an effective ground fault current path. Burn that sentence in your mind. This is why we don't ground ham antennas with a ground rod 100 foot away from the service entrance ground. Remember that. Notice all the green stickers here. This is a very complicated topic that's spread out through this chapter. I'm going to step through these one at a time. It's important here to go from grounded system, which is a supply system, in Article 250.4 to go over to 250.24a5. This is 250.24a5. Notice the change. Load side. Supply side is the utility pole, the wires to the house, the meter, the breaker box, the main breaker, the meter conduit, all that stuff that essentially belongs to the utility. After the main breaker, that's in my house, that's the load side. The load side has branches that come from the service through the branches out to the ham shack, to the washing machine, to the TV, to whatever in the house. Load side grounding connections. A grounded conductor shall not be connected to normally non-current carrying metal parts of equipment. That's your ham rig. To equipment grounding conductors, or be reconnected on the ground reconnected to ground on the load side, not supply, but load, of the service disconnecting means. That's the main breaker, that's a pull-out handle in a disconnect box, except as otherwise permitted in this article. Except as otherwise permitted in this article is a critical phrase. There are generally two concepts here. There is the utility company, generally 60 cycle, what we call commercial power supply, and then there are separately derived systems, another critical point. That's what this exception is referring to, separately derived systems or generators. Maybe a solar system, something like that. Let's flip pages here. Let's talk about ground rods. Grounding electrode. The grounding electrode shall be as near as practicable to, and preferably in the same area as the grounding electrode conductor connection to the system. That's not the radio. That's essentially the power service from the pole and the ground rod at the service entrance. The grounding electrode shall be the nearest one of the following: water pipe grounding, structural building ground, so on and so forth. Shall be near as practicable to and in the same area, not 100 feet away, not around the corner of the building. There are reasons for that. Focus phone. Part 3, 250.50. Grounding electrode system. That's ground rod. Grounding electrode is a ground rod, a pipe, whatnot. Grounding conductor is a wire and a cable running through the walls of the house. Maybe a ground wire to the washing machine in the wet basement, which is a wet area. But it's important to understand the difference. They don't necessarily call it a ground rod, because more than ground rods can be used. All grounding electrodes described in so on and so forth, present at each building or structure served. Notice it's referring to the system, power to the building, shall be bonded together to form a grounding electrode system. (250.58) Common grounding electrode, where an AC system connected to the grounding electrode in or out of building or structure. There's the service side. The same electrode shall be used to ground conductor enclosures and equipment, building and structure, separate services, feeders, branch circuits, supply building, etc., etc. The same grounding electrode shall be used, not a separate one. Yes, I'm shouting at you. Not a separate one. Only one. You might pause here and search for information on the different kinds of grounding systems. There are topologies: star, ring, whatever. We tend to avoid ground rings or loops in radio because they tend to cause feedback and oscillation. That's very bad. Focus. Table 250.66, grounding electrode conductor. Grounding electrode conductor, that's a ground wire for alternating current systems. Not, I repeat, not lightning. The size, the cross section of the ground conductor. See the first entry here, number 8, number 6. Let's just look at copper 8, 6, whatever, is based on the size of the conductor essentially bringing service to the building. If it's a 2-aught aluminum from the pole, it's number 6, and that's what's on my house. This is not sufficient for lightning. So do not pretend that a number 6 wire is sufficient for lightning protection, because it may not be. Nothing in this article here mentions length, and that is critical. This only mentions the proportion of conductor diameters. length is critical, especially in dealing with transients like lightning. I mentioned in the first video that this book says essentially nothing about lightning protection. Here's what it clearly says about lightning protection systems. Come on, get me focus. I love my cheap videos. 250.106 Lightning Protection Systems. The lightning protection system ground terminal shall be bonded to the building or structure grounding electrode system. That's essentially it. Why? Because it's far too complicated for this book. Next. And 10 minutes is going to be a long video. It's a bit hard to process and upload these, so I'm going to stop and pick up with the critical point about equipment connected by cord and plug, and radio equipment and washers and dryers and such, and the 1920s in the next video from 250-114.